Assalamualaikum. My name is AINA MAISARAH. My metric number is DD220103. Today I'll be talking about hydrotreated vegetable oil or HVO, a sustainable and renewable diesel fuel substitute. Due to concern about air pollution, climate change, and the limitation of fossil fuels, there is a growing interest in finding cleaner energy sources. HVO, also known as green diesel, is a promising alternative. HVO is made by transforming fat into high-quality diesel fuel. This process involves several steps: hydrocracking, hydrogenation, isomerization, distillation, and also fractionation. So, HVO is important because it helps address environmental issue and promotes cleaner energy. It's made from renewable sources like animal fats and vegetable oils, which reduce our dependence on fossil fuels. The production processes of HVO involve hydrocracking, which is breaking down large molecules. Second, hydrogenation, adding hydrogen to improve stability. Third, isomerization, which rearranging molecules for better fuel properties. And lastly, distillation and fractionation, which is separating the fuel into different components. HVO has significant environmental benefits. It reduces sulfur, nitrogen, and oxygen compounds during production, leading to cleaner fuel. It also decreases emissions of particulate matter, sulfate dioxide, and nitrogen oxide. So as a conclude, HVO is an important step toward cleaner and more sustainable energy. It offers substantial environmental benefits and reduce our reliance on fossil fuels.
Okay, Assalamualaikum. My name is Muhammad Ammar ABIDIN. So today I want to tell about equipment specification. First, F101 is vertical tank for furnace, and R101 vertical vessel for the oxygen generation, and then P101, 103, 104, 105 is gear pump, and BT101 vertical vessel pre-treatment, and then E101, 102 is exchanger for cooling, and T101, 102 is vertical vessel for distillation. VE104 is horizontal tank CGD receiver, and A101 is vert tank MA unit, and C101 is compressor. And then R102 is vert vessel isomerization. For VE105 is vessel naphtha receiver, and P102 is diaphragm pump, and stream to 24, 35, 36, 37, 38, 39, half is a pipe, and stream 13, 14, 15, 16, 17, 18, 19, 22, 23 is same for one inch pipe, and stream 1, 2, 3, 4 and 1 until 21 is second pipe, and E105, 106 is exchanger for reboiler, and BV101, 108 is ball valve, and V102 and 105, 106, 107 and 110 is globe valve, and for the last is French for fitting.
Assalamualaikum, my name is ATIQAH. So for further discussion, I will explain about 5 components or equipment that we use in this study. So the first one is the rotary pump, the second one is heat exchanger, the third one is compressor, the fourth one vertical vessel, fractional columns and reactors, the last one is the pump sizing. So for the rotary pumps, we use rotary pump instead of reciprocating pump because they are comparable, and rotary pumps discharge material at a steady, smooth flow by means of mechanical components like gears, screws or piston. We use rotary pump because it will function without causing severe pressure spikes that reciprocating pumps are known for. So the typical heat exchanger mechanical device we use makes the heat transfer between commodities is the main purpose of an exchanger in a pipe system. So the exchanger can achieve both cooling a product for long-term storage or heating liquid to the required temperature. So the next is the compressor. While the compressor and pump are very similar, the compressor is made to transport gases, air or vapors rather than liquids. A compressor is a device that speeds up the movement of a gaseous commodity from one place to another. So since gases are elastic in contrast to liquids, flow rates must be increased by compressing them. It goes without saying that liquids cannot be compressed unless you're creating a hydraulic application. Like pumps, there are three different configurations available for compressor. It's a centrifugal, reciprocating, and rotary. So for the vertical vessel, fractional columns, and reactor, the vertical vessel is a cylindrical vessel whose long axis is perpendicular to the horizon, configured as a fractional column. This vertical vessel have internal plates called trays, which 8. So for the last is the pump sizing. So several pumps in a plant may be used to transport pump oil from one vessel to another. So the first one is gear pump. It's a positive displacement pump that widely found in aboard ships. So second is the most used pump in the world for moving heavy oils. It's the centrifugal pump. And for the third one is the displacement pumps, specifically designed to move viscous liquids such as palm oil are known as rotan pumps. And the fourth one is the barrel pumps are available in ABDF, polypropylene, and other materials.
Now I will present about the result part. This part I will present more cost of the equipment that we use for the design. First, we use the 5 vertical tanks, so that the total cost for this vertical tank is 452,990. Then we use 6 vertical vessel, so the total cost is 217,435.20 cents. Besides that, we also use the pump. The pump we use is 4, so that the total cost for pump is 6,524.5.8. Next, we also use the diaphragm pump. The diaphragm pump is 268.17. Next, we also use the two of the heat exchanger. So the total cost for this is 6,323.92. The compressor we use is 8,726.79. The horizontal tank is 1,811. The vertical heat exchanger is 1,811.96. The heat exchanger flush drum is 2,672.95. The heat exchanger revolver is we use 2, so that the total cost for this is 3,623.92. So that the total cost is 702189.37. Now I will present about the second part of result. This part I will present about the cost of flash, team joint, golf valve, ball valve, elbow, and pipe. For this part, the total cost for all is 6450313.45. For the last part of result, I will present all the costs. For the total material cost is 7152502.82. For the labor cost is equal to 0.3 times material cost, so that the final cost is 2145750.85. The construction is 15% of labor, so that the total cost is 1072,875.41. The overhead is 15 of material plus labor plus construction, so that the total cost is 974.877.97. The total cost is equal to the total material cost, the total material cost plus labor cost plus construction cost plus overhead cost, so that the final total cost is 17166,006.75.
My name is Muhammad Arafat, metric card number BD220013. I'm going to talk about the analysis on our design of the green diesel production process plant. The analysis is based on four elements. The first one is sustainability. The analysis on the sustainability is aligned with the plan, goal, operation, and overall business planning. It comprises three components: social, environment, and economic studies, aiming to protect the company by understanding future environment and resource needs. And the hydro treatment vegetable oil is highlighted as sustainable biofuel production method, using heat rather than chemical process, enhancing renewability and climate change performance. Proper pre-treatment technique for feedstock are emphasized to improve the finished product quality. Economically, the objective is to implement a carefully planned factory to ensure sustainability and profitability. And second, based on our analysis on the economic, we know that every phase of the biodiesel production plant, from raw material procurement to processing, manufacture, storage, and marketing, impacts the product's economic viability. The price of biodiesel is crucial for its adoption and use. The team's economic plan to ensure the factory will be profitable and sustainable by minimizing unnecessary equipment usage for a more economical and efficient process flow, and focusing on enhancing the product longevity beyond its manufacturing process. And the third element on our analysis is environment. Sustainability involves protecting natural resources and global ecosystem to ensure the health and well-being of current and future generations. The ecological component often receive the most consideration in sustainability efforts. Companies are working to minimize water usage, reduce packaging waste, cut carbon emission, and address other environmental issues. Biodiesel production facilities should be strategically located and designed to prevent disruption and ensure the safe positioning of equipment. Using environmentally friendly materials such as carbon steel, which is highly sustainable and has no negative environmental impact during its manufacture or use, is crucial. And lastly, social strategy. Social sustainability involves understanding and managing the range of impact the price have on people, including both positive and negative consequences. The relationship and engagement a company has with its stakeholder are crucial, affecting the welfare of workers, value chain participants, consumer, and local communities. Effective management of this diverse impact is essential. Collaborating with government and non-governmental organization to create public awareness program can highlight the benefit of biofuels and their positive impact on daily life. So that's all for the analysis. Thank you.